Okay, let's talk some more about the other things you might do with the analysis menu. So I'll click on the colorful TV icon in the upper right to bring up the analysis menu, and I'll select left image. So image, select left image, which is the topography image. Usually that's where you want to do your analysis. There are two main things that you might want to do. If I go to View, Top View, this brings up a generic box where I can adjust, let's say, the data scale, which is cosmetic only. Right now it's set for 80 nanometers. I can set it to, let's say, 120 nanometers if I want to have a bigger range of data scale. And I can also adjust the color contrast, which just changes how the range from black to white is mapped. So higher color contrast means that the change occurs in a smaller interval near the average Z value, and lower color contrast reduces the contrast, so most of the time you want to keep this close to 0. And color offset, let me increase the color contrast again so we will see this more clearly. Now when I change the color offset, it's going to change where in this range from 0 to 120 nanometers does the transition from black to white occur. So depending on the particular image and what part of the image you want to pull out, you need to adjust the data scale, the color contrast, and the color offset so that it's displayed in the nicest way possible. And as long as you always include this Z-scale bar along with the image, it's still possible to interpret the data in a meaningful way. I'll quit out of that. The main other thing that you need to know about for the analysis menu is under Analyze, it's Section. This is how you take cross-sections, which is the easiest way to quantitatively measure height differences. I go over to this right-hand screen and draw a line across where I want to take a cross-section. In order to draw a line, it's the same sort of strange mouse system where I click once, release, then move the mouse, so it's not clicking and dragging, and then click a second time to determine the line. And it always automatically extends the line to go all the way to the edges of the image. Usually, if you're working with a flattened image, it is preferable to take a cross-section that's perfectly horizontal so that it will be affected as little as possible by the flattening process. If I had a step in my sample that was horizontal, the height of that step would be strongly affected by the flattening process. Whereas if I have a step that's vertical, the height of that is not affected by the flattening process. So when possible, you want to do a cross-section that's perfectly horizontal. Once you draw the cross-section, it brings up this graph here, and there are two markers. I can click and let go on one of them, and now I can move this around and, let's say, position it to the top of a peak, and then I can click and let go on the other one and move it to the bottom of that peak, and then click again to release it. And then over in this window, it tells me the horizontal distance between those two, 39 nanometers, the vertical distance, 15 nanometers, and the angle, 21 degrees, between those two. You have to resist the temptation to click on them in the image, because if I click on them in the image, it makes the line that I have selected disappear.